After the age of Sahelanthropus and Auroran, another ancient primate stepped into the scene, one that carried traces of both ape and hominin, but in a way that still sparks debate today. This is Ardipithecus kadabba, one of the earliest known members of the Ardipithecus genus. And its story is all about transition, the slow, winding shift from last common ancestor with chimpanzees towards something that starts to look a bit more like us. Please note that there were not enough skull fragments to determine what the head of kadabba would have looked like. Let's dig into it. Ardipithecus kadabba was discovered in Ethiopia, primarily in the Middle Awash region of Afar, a literal treasure trove of early hominin fossils. The kadabba fossils were discovered by paleoanthropologist Johannes Haile-Selassie, leading a team from the Middle Awash Research Project in Ethiopia. With the first finds in 1997 and later described in 2001 as a new species within the Ardipithecus genus, though later research by Haile-Selassie and colleagues formally defined it as its own distinct species in 2004. It was described by Johannes Haile-Selassie and colleagues based on surprisingly diverse set of fossils. Even if none are complete, these include multiple teeth, a toe bone, pieces of jaw and mandible, and fragments of limb bones. Not a full skeleton, far from it, but each piece gives us a small part of a much bigger evolutionary puzzle. Originally, kadabba wasn't even considered its own species. It was lumped as a subspecies of Ardipithecus ramidus, A. ramidus kadabba. But in 2004, researchers argued that its teeth were more primitive and more ape-like, so it deserved to stand on its own. In evolutionary terms, kadabba is almost like the prototype version of Ardipithecus, a trial run for traits that will later become clearer in ramidus. Kadabba lived between 5.8 and 5.2 million years ago, putting it at a fascinating point in time. Younger than Auroran, younger than Sahelanthropus, but older than Ardipithecus ramidus, which lived 4.4 million years ago. So if you're visualizing a timeline, kadabba sits right in the murky middle, extremely close to the base of the human family tree, but just late enough to show early steps away from our last common ancestor with chimps. We don't have a skull. We don't have a complete limb. But the fossils we do have reveal something surprisingly important. One, the toe bone, the star of the show. The proximal pedal phalanx is a fossil that made headlines. Its curvature and joint surface hint towards a form of push-off during walking, something that isn't chimp-like. But here's the catch. It's not fully human-like either. It lands somewhere in between, fueling a long-running debate. Some researchers argue that it supports early bipedalism. Others think it belonged to a tree-climbing primate that occasionally walked upright. 2. The teeth. Kadabba's teeth tell a second, equally important story. They preserve an early reduction in classic ape-honing complex, the system where the upper canine sharpens itself against the lower premolar. Chimps use it for fighting and dominance displays. In kadabba, the system was already starting to shrink. This dental change becomes a major theme in early hominin evolution, signaling shifts in social behavior long before the brain gets big. 3. The body plan. Scattered limb fragments suggest kadabba was comfortable in the trees, but also experimenting with upright walking. Not a dedicated biped, not a knuckle walker, something transitional. Kadabba lived in what paleoecologists call a mosaic environment, a patchwork of woodland, shrubland, forest edges, and seasonal river systems. Not a grassland, not a pure forest, something in between. And this is important because it supports the idea that early bipedalism didn't begin in the open savanna. It began in complex wooded landscapes filled with climbing opportunities. This is where paleoanthropologists start arguing over coffee. There are three main ideas. 1. Direct ancestor. Kadabba, Ramidus, Australopithecus, Homo. 2. Close cousin. Related, but not necessarily linear. 3. A side branch. An evolutionary experiment that didn't lead directly to us. Most experts agree on one thing. Without more fossils, we simply can't close the case. But Kadabba does show early signs towards bipedalism, early changes in canines, a habitat consistent with the earliest known hominin behavior. It's one of the species that bridges the gap between our earliest possible ancestors and more confident bipeds that appear later. So, whether Kadabba is a direct ancestor or just an evolutionary experiment, it captures a moment when evolution was trying out new ideas, new teeth, new movement patterns, new ways of living. And up next in this story is a species that gives us a much clearer look in these early transitions, Ardipithecus ramidus, better known as Ardi. Make sure you like, subscribe, and comment for more of that deep dive right here on Fossil Matrix.